Yes, graphing by hand. Label the vertical scale on the left, molarity, with parentheses, M, sodium chloride. All right, so I'm going to start actually making my graph, and you can follow along. And I'm just going to take a couple pieces of paper underneath of it so that I don't make too deep an impression on my desk. Okay, so here's my graph. I need to back out a little bit so you can see the whole page. And it says, label the vertical scale on the left, molarity, sodium chloride. So I'm just going to label this. That says molarity, and then in parentheses, capital M, sodium chloride. And it suggests that you begin at 0 at the bottom and go all the way up to 2.00. So I'm going to have 0 on the bottom. I'm going to have 2.00 at the top. And if there are, and I'm going to go ahead and take a separate sheet of paper right now. If I'm going from 2.00 molarity to 0.00 molarity, and there are 50 squares, I can then calculate how much each square is by doing 2 minus 0 divided by 50. Each square is 0.04. So this square right here is going to be 0.04. And I'll zoom in on that so you can see it. And I will even get a nicer pen. So the very x-axis is 0. The first square is 0.04. And of course, those are going to be units of molarity. And let's see. So I always label my first square so I know how big each square is. But if each square is 0.04, then the next one's 0.08. 0.12, 0.16, and the fifth square is 0.2. And what I'm going to do from now on is I'm going to count every 5 squares. And call that 0.4. Any questions about how to label this axis? Because I'm going to take the next next minute or so and just go all the way up to the top. And I just sort of wrote over my units there, but that'll be all right. One point zero. 1.2, 1.4, 1.6, 1.8. And just to let you know how I chose these numbers is that my largest molarity is 1.69 molarity. And so that's 1.7. And 1.7 is all the way up more than 3/4 of the page. And I'll plot it once I've got both my axes on here.
I have a question, Professor.
Yeah, Demet.
And what happened if someone's molarity is more than 2?
If your molarity is more than 2, that's fine. You're going to come back to this calculation I just did. And Dimith, what is your largest molarity?
I found 3.
3.0 or 3 point something something?
5.
3.05 or 3.5? I'm sorry.
0.5, 3.5.
3.5. I would guess there's supposed to be one more significant figure there, so just make sure.
3.5, 3.
There we go.
Excuse me.
Hold on just a second, Zanger. Let me talk to Demith for a minute. So, how many grams of salt did you use, Demith?
This is for 5 grams.
Yes, did you use about 5 grams?
Yes, Professor.
Okay, so Demith, what we're going to do is, so if you can see that I have 4.94 grams, and I ended up with 1.69 molarity. So I think we're going to go revisit your calculation and make sure that everything worked out.
Okay, my gram of salt was 5.02.
Yes. So 5.02 should still work out to be less than 2.
Yes, maybe I made a mistake somewhere.
So let's fix that mistake later. For now, you're going to make the graph that I'm making, okay, Demith?
Okay.
Good. Yeah, we'll take care of everything. Zanger, go ahead.
Is this going to be recorded?
This is being recorded.
Okay.
All right. So now let's do the x-axis. And again, following along on page 6, part B, number 5 now. Label the horizontal scale on the bottom. Oh, this says each box. So number 4 says each box represents 0.05, but I think that's wrong. I think it should be 0.04. But anyway, it works out. So now 5, label the horizontal scale on the bottom density. With units of grams per milliliter. Begin at 1.000 and end at a value of 1.100. It's 50 boxes wide, so each box will be 0.002, and this is correct. So I'm going to turn my paper this way, and my x-axis is going to be 1.000, and each box is 0.002, so this first box will be 1.002. And after that, I'm going to just label every 5. So this will be 1.010. Go 5 more. And I don't know on your graph paper if you can see it, but every 5 lines, the grid lines are supposed to be a little darker, so that can help you keep track of where everything is. 1.020. 1.030 every 5 boxes. And keep going until you've gone all the way across. And I haven't taken roll yet, but I'll do that in a little bit. Any questions about the x-axis?
What did you just say now?
Oh, I just said I haven't taken roll yet, but I will in a little bit.
Okay, thank you.
Yep. All right, I'm going to zoom back out a little bit so you can see my whole piece of graph paper. And it looks something like this. It's oh, so the one thing I did not say, it doesn't look like, is that I need a title on my graph. And a fine title will be molarity versus density for saline solutions. And saline is another word for sodium chloride, so you could also do molarity versus density for sodium chloride solutions. That would be a fine title. You do need a title. Now the next one says, number 6 on page 6 says, plot your 4 data points for the 4 solutions of known salt concentration. And it says there's a video with that, but we're making a video for that. So my first solution that I'm going to plot has a molarity of 1.69 molarity, sodium chloride, and it has an average of 1.082 grams per milliliter. So my first data point is 1.082, so I have to go all the way over to 1.082, which will be this box right here. So one box beyond 1.080. And then I have to go all the way up to 1.69. And for me, I have 5 boxes to get from 1.6 to 1.8. That means that halfway in here is 1.7. And right here is actually 1.68. So I'm going to have to be halfway between there. And now what I'm going to do is wherever 1.69 is, I'm going to go all the way over. And wherever 1.82 is, I'm going to come all the way up and I'm going to make my first data point. And let's see. So I'm at 1.082. And my first data point is right there. And you're going to do your data points. So, but your data points should be, so if you had roughly 5 grams, which I do, then your molarity should be roughly 1.7 molarity or 1.7 something molarity. Could be 1.8 something, could be 1.6 something, could even be a little farther off, but it should be in that range. And your average and standard, your average for your density, 1.08, could be 1.07, could be 1.09, shouldn't be too much farther than that, but it is possible. And please plot your data point.
Professor, mine is 1.024. Is that okay?
So 1.024. I think we talked to Miwa about this, and we will. So what we said was that's a little low, but we're gonna plot it and we're gonna see what we get.
Okay.
Yes.
I found my 1.23.
Plot it up. We'll see what we get. So my take on this is that that's the data you have, and you always go with the data you have, and that you are still eligible for full credit, even if your data is a little off, as long as we do all the things we need to do correctly as far as calculations, and this week as far as plotting. And
okay, Professor, I want to know if you did you approximate your molarity?
Say that again, please, to me. What I missed it.
Sorry, did you approximate your molarity?
Did I approximate molarity? You mean when I plotted it?
Yes.
Well, so in some ways, yes. So if I'll zoom in for a second here. So this line that I'm pointing to right now, that is 1.68, and the middle is 1.70. So I did the best I could to get 1.69, and I actually made my dot a little bigger than I need to so that you all could see it. But but it can be small, or just make sure that it's visible to you. And and I will be looking to see it when you upload a PDF of your plots, your graphs. So yeah, but again, it is an approximation. Yeah, good point. Any other questions? All right, so let me zoom back out. Hopefully you don't get easily seasick. Okay, so we did this point here. So this was our first point. And our next point is going to be right here. It's going to be 1.027, 0.338 molarity. And so I'm going to go to 1.027. So that's going to be halfway between two lines, because one of these lines is 1.026, 1.028. So I'm right in the middle there. And then 0.338, well, let's see. Here I have 0.3, and then 0.32, 0.34, 0.36, 0.38, 0.4. So 0.338 is about 0.34, so I'm going to be right about in the middle of that box. And then I'm going to go over and have them meet. Right there.
I had a question. My density for the diluted solution was 0.887. What should I do in that case?
Well, if your density is less than 1, then you still have to graph it. So what you're going to have to do, and this may be for a number of students, is if your axis starts at 1 and your data is at 0.887, then we're going to have to talk about how to redo your x-axis. Actually, let's talk about that for a minute. And what I do want to say is, so I only have 2 points because I only did the 5-gram solution. So everybody else who's ready, go ahead and graph for your 3.5 gram solution. And what I will tell you is that in general, your 2 points, so you're more concentrated for the 3.5 gram should fall somewhere in here. And your more dilute, or sorry, your first solution should be somewhere out here, and your second one should be somewhere down here. But again, let's see how it turns out. So, but now let me talk to students. So, sorry, was that you, Fazumana, who said you was 0.887?
Yeah.
Okay. So now let's talk with students. And I just need a piece of paper. There we go. So Fazumana, what is the lowest density that you have for your 4 points?
Density I have is the 0.887.
And what's the highest one you have?
The highest one I have is 1.01.
Okay. And okay, so here's what we need to do. So whatever you do, you take the range of them, 1.01 minus 0.887, and you divide it by your 50 squares. All right, so, and this is for you, Fazumano, okay? And so 1.01, although the process, this is the same for everybody, 0.887. I get 0.123 divided by 50. Let's see. Yep. So here, the number we get is 0.00246. And this is the sort of the change in each box, so per box. And that's kind of a weird number, so I'm going to suggest we go to, how about 0.004? And you're going to start at 0.8. Let's see if this works. if you go from 0.8 to 1.01, okay, that's going to be a little not enough. So, Fazimana, I want you to make every box 0.005.
All right.
And you're going to start on your x-axis at 0.800 and go all the way across. And it may or may not get to 1.01 exactly, but you'll make it to at least 1.01.
Okay, that's good then. All right, I'll change it now then.
Yeah, sorry about that, but that'll help. Does anybody else have any points below 1.0 for their densities?
Yes, mine.
Demith, what's your range of values?
It goes from 0.934
Teacher, where she really just kicked you out?
to 1.019.
1.19?
No, 019. 1.019, yes.
Got it. Okay. So let's do yours now. So 1.019 minus 0.935 divided by 50 squares. So, and that gives me 0.00168. And so, let's see. So I would like you to go from 0.9. Let me make sure it works out first. Not quite. So, 0.9, you're going to go from 0.93,
Oh, whatever.
and each box is going to be 0.002. Okay, Demith?
Okay, Professor.
So yours starts at 0.93.
Try doing that.
Anybody else have numbers less than 1.000?
Yes, mine is less than 0 points.
And what do you have, Aziz?
The first one is 0.965.
Uh-huh.
The second one is 0.99.
What's your highest one?
The highest one is 1.083.
And what is the 0.965 your lowest one?
Yes.
Okay. So, all right, let's see here. So just going to take the full range. Let's see. So you're going to start at 0.96, and each box is 0.004. Aziz, does that sound okay?
Yes, thank you.
Sure. Anybody else?
Professor?
Daryl, yeah.
Yeah, so I'm plotting my points, right?
Uh-huh.
And let me see, maybe I can turn my camera on and show you what is happening. Okay, nothing's happening. I don't know why. Well, the thing is this, the density, right?
Uh-huh.
Since it's at my second density for 3.5, it's 1.045 plus or minus 0.029. And plotting it, I'm seeing the graph is supposed to be like almost a straight line, but then the point when I plot 0.1.045,
Uh-huh.
it distorts the graph. So I'm asking, can I subtract the 0.2 due to the standard deviation? Can I subtract that, because it makes more sense if I subtract the 0.029 and plot it? The graph aligns itself quite well, not really in line, but at least it looks better.
Okay, so the first answer is unfortunately no. But
Oh boy.
Daryl, or what you're describing is that you have something like 3 points that make a nice line and 1 point that's way off.
Yes. But
Okay.
in this case, it's the lowest point.
Right. And so so here's what you can do. So if we were in a lab doing this lab, for our jobs, we would say that the point that's way off the line is pretty clearly wrong. And so what we would do is we would redo it. Okay? Not that we have to redo it now, but if you had a point that was way off the line, you'd want to redo it, right?
Yes.
And but we don't have to redo it here. So if you have 1 point that's way off the line, you can make a note on your graph that says ignored this point. So we will never change our data, meaning to make it look pretty, to make it fall on the line. But what we will do is, and this is what I do in class with students all the time when we're in face-to-face, is I say, well, it looks like we don't know what happened, but something almost for sure went wrong with this point. So you should feel free to ignore it, and then we'll draw our best fit line through the other ones. Okay?
I see. So the standard deviation, we don't use it to make our points look good, or we don't change the points. No.
Correct. So the only thing we use the standard deviation for this lab is to understand our precision for each point. So you're right, though. If you had a point down here and its standard deviation made the error bars like this, so bigger than the whole graph, that would raise other issues. Like if we had very large standard deviations, then again, we would want to do that data over again, because large standard deviation tells us that our data is not precise. So, and what I'm concerned with in our lab is that we learn these things, like when to recognize good data and when to recognize data that we would have to redo.
Okay.
Yeah.
Thank you,
So just,
Professor.
yeah, sure. It's a good question. Lots of good questions today. Any other questions? Okay, so not hearing any questions right now, let's head back to our graph. And so, like I said, I only have 2 data points, but let's suppose that I had 4 data points. So, and I don't know, do I have any other data points here? I don't think I do. Nope.
Professor?
Yeah.
Can I ask a question real quick?
Of course.
So in physics, well, some graphs we plot in physics, you put a point and you put a little circle around it. Why can't we do that in chemistry?
Oh, so Daryl, you mean a circle to represent the standard deviation?
No, just plotting the points. When plotting your graph, they put a point and then a little circle around it, because, well, when you draw your line, it might pass, when it passes, it might not pass exactly on the point, but if it passes within that circle, it's kind of cool. It's okay, I guess.
Right, it's okay. No, so actually that's not a bad technique. That's fine. But what we will see is, so let's see. So feel free to do that, right? But I would wait just a minute until I take you through number 7, which is making a best fit line by hand.
Oh, okay.
Okay, because we're gonna make a best fit line, and I'll talk about how to do that. And those circles you're talking about can be helpful, and you may want to do them and you may not. Okay, so I'm going to put 2 more points on here. So I'm going to put one down here and one over here. And so I don't have these data points, but I want you to have 4 points on your graph when we make a best fit line. And I just happen to have a see-through ruler. You don't need this. In fact, I usually don't have one. But so is there anybody who needs more time to put on their 4 data points?
I do.
Okay.
I'm a little bit confused on what.
So to me, what you're going to do is once you get your new set of axes, you just want to plot each of the, there are 2 points to plot here, and then you'll have 2 more points to plot for your 3.5 gram sample. And it'll be always average density versus molarity, average density versus molarity.
Okay.
Okay.
So I have for under my 5 grams, I have 0.990 as my density.
Uh-huh. So you're going to plot that at 0.990, and that should be a position on your x-axis for your new graph. And I'll tell you what, I think we're going to have time for questions after we do this next step. So I'm going to go ahead and do the best fit line. This is page 6, number 7. And as oftentimes happens in chemistry, so our points don't fall exactly on a straight line, but we are going to fit what's called a best fit line through them. And when we do it, it says this. So it draws the best possible straight line through your 4 data points. The best fit line will go as closely as possible through all 4 data points and does not have to go through the corner of your graph. With 4 points, the best fit line will have 1 to 2 points above the line and 2 to 3 points below the line and minimize the total distance between the line and the 4 data points. So if you're looking at my data points, and I'm going to get as zoomed in as possible here so you can see my 4 data points. There we go. So I can see that I want all 4 of my data points. So I'm going to have 2 of them above the best fit line and 2 of them, there's one right here and there's one right there below the line. And it doesn't matter, it's not always like this, but can you see that the distance between the ruler and this red point and the distance between the green point and the ruler are approximately the same? And the distance between the green point right here to the edge of the ruler and the red point to the edge of the ruler are approximately the same. That's what you're going for. You want whatever points are above where you're going to draw the line, which is the edge of your ruler, to be the same distance from your line as the points that are under it. And so I'm going to hold my ruler down. I'm going to attempt to draw a best fit line now. Oh, I just moved. Let's try that. All right. So there's my best fit line. And what I'm trying to say is the point down here and the next point are approximately the same distance to the line. And the point here and here are approximately the same distance to the line. And it doesn't have to be these points in this order. It just so happened that whatever points are above the line and whatever points are below the line, the distance to the line is about the same. And when we do this in Microsoft Excel in a few minutes, Microsoft Excel will actually make the best fit line by looking at the square of the distance above and below the line. But we We just want to do the best we can. So are there any questions about how I drew this line? Okay. Well, so let me do another example then. And so let's say we have 4 points that look something like this, and we want to draw a best fit line. Then our best fit line here would go somewhere right there, where again, 2 of the points are above the line, 2 of the points are below the line, and on average, they're approximately the same. Like the line goes, that's what it means to go as straight as possible through the 4 points. So please draw your best fit line for your graph. And it doesn't have to be perfect, it just has to be pretty good, meaning it has to go through all of your points as best as possible. And this graph is now done. Does anybody have any questions about this graph?
Excuse me, Professor. The 2 points in right, do we put them like just like that? Or is there anything that help us putting them around there? Or should we just put them just like that?
So Dimit, you're graphing your 4 data points wherever they are, right?
Right.
And then you're drawing a line that goes as close as possible to the exactly between all your data points as possible. So yours may look pretty different. So your data, so I had another example here. Your data may look more like this, or your data could look more like that. Whatever you do, draw a best fit line that goes somewhere between all 4 of your points.
Okay.
And if you have any questions, I'm happy to look at it. Remember, our goal in lab is that you turn in work that is 100% correct, and I'm happy to check it. Either, and I think we've been doing this, which is you can email it to me or show me on camera, whatever works best for you. So that, because my goal is that you get 100% on this lab. I am going to stop recording right now because I'm going to make a second